A mini-tank rolls toward enemy lines, 1 foot tall, 4 feet long, packed with explosives. Remote-controlled by wire. The Germans called it Goliath. The Allies called it Beetle Tank. Doodlebug, target practice. By 1944, 7,564 of these machines crawled across European battlefields. Most never reached their targets. Cables snapped, tracks jammed. Small arms fire punched through 5mm armor like paper. Polish resistance fighters in Warsaw sent volunteers sprinting into SS fire just to cut the control wires. British troops on Normandy beaches watched artillery shells sever the cables before the Goliaths traveled 10 meters. At Anzio in April 1944, German engineers tried using them against entrenched Allied positions. Artillery found them first, yet Germany kept building them. 3,000 Reichsmarks per electric model, enough to buy a car, for a weapon that exploded after one use. Why did the Wehrmacht invest in what became one of the war's most expensive failures? What did they think this crawling bomb would accomplish? This script is researched and factual, using sources from the German Federal Military Archive's technical specifications published in their armored vehicles. Compendium dated November 2025, and combat deployment records from the U.S. Army Center of Military History's Anzio campaign documentation dated July 2018. These are deep archival sources, cross-referenced with unit records and engineering specifications. Now back to the information. Became head of Tsar Nicholas II's Imperial Garage. Invented the half-track system. Pioneered dual-clutch transmissions. Returned to France after World War I. Joined Citroën. By 1939, he was developing small guided tracked bombs. Wehrmacht Ordnance Office recovered his prototype from the Seine in late 1940. Examined it. Saw potential. Ordered the Carl F.W. Borgward Automotive Company in Bremen to reverse engineer the design. The requirement? Carry minimum 50 kilograms of explosives, deliver it remotely, make it expendable. The name choice showed German military humor, like calling the super heavy Panzer VIII the Mouse. Mouse, a vehicle weighing 188 tons. Goliath measured 1.5 meters long, 0.85 meters wide, 0.56 meters tall, 370 kilograms empty weight, twin electric motors, 2.5 kilowatts each, maximum speed 6 miles per hour. 2 internal batteries. Operational range 1.5 kilometers on roads, 0.8 kilometers off-road. Explosive payload 60 kilograms. Control system, triple strand cable stored on rear drum, 650 meters of wire. Joystick control box. 3 wires for steering left, steering right, and detonation. Front armor 5 millimeters. Sides unarmored, top unarmored. Production began April 1942. First units issued to Panzer Pioneer Companies 8, 11 through 8, 15. Army Pioneer Battalion, Motorized Special Purpose 600, codenamed Typhoon, Typhoon. The electric motors proved temperamental. Batteries required constant recharging in field conditions. Repair took hours. Maintenance was difficult. The motors were expensive to manufacture. The Wehrmacht needed something simpler, more reliable, cheaper. Zundap used their own air-cooled 2-cylinder 2-stroke motorcycle engine, 700 cubic centimeters, 12.5 horsepower. This engine was mass-produced for Zundap motorcycles. Parts were everywhere. Mechanics knew how to fix them. The new model weighed 430 kilograms, measured 1.62 meters long, carried 100 kilograms of explosives. Range extended to 1.2 kilometers on road, 0.73 kilometers off-road. Maximum speed 6.8 miles per hour. Front armor increased to 10 millimeters on later variants. Sides still unarmored. Control system unchanged. Same 650-meter cable, same joystick, same vulnerability. Rhino and Zackert's companies built another 1,900. Total gasoline Goliaths, 4,900 units. Total production, both models, 7,564 units. Cost of gasoline model, lower than electric but still expensive. Still single use, still expendable. The Wehrmacht assigned them to 6 dedicated Panzer Pioneer companies, specialized units trained specifically for Goliath operations. The weapon became part of Germany's Wunderwaffen propaganda in the final war year. Wonder weapons. The propaganda exceeded reality by enormous margins. 89 vehicles, each weighing 65 tons. Frontal armor, 200 millimeters thick. Armed with 88 millimeter PaK 43 gun. 654th Heavy Tank Destroyer Battalion. Problem, Soviet minefields. Extensive defensive belts. Mines everywhere. Standard procedure required engineers to clear paths manually. Slow, dangerous, high casualties. The 312th Panzer Company radio control had a different tool. Goliaths. The small tanks rolled ahead of the Ferdinands, detonated mines, cleared roadblocks, successfully. This marked one of Goliath's few documented operational successes. The mine clearing worked, the Ferdinands advanced, but Kursk still became a German defeat. Soviet defenses held. German offensive stalled by July 13th. 2 weeks of fighting. 43,000 German casualties, 177,000 Soviet casualties. Germany never regained offensive initiative on the Eastern Front. Initial landing unopposed. 36,000 men ashore by midnight. 13 killed, 97 wounded, 44 missing. Germans caught completely by surprise. Within days, Field Marshal Albert Kesselring rushed reinforcements. 25,000 German troops surrounded the beachhead. The stalemate lasted 4 months. February 16th. Germans launch Operation Fischfang, major counterattack. German forces push Allies dangerously close to the sea. 4 days of brutal fighting. Allies suffer 3,500 casualties. Germans lose 5,400. Neither side breaks through. Most Goliaths destroyed before reaching targets. Allied artillery spotted them easily. The low profile helped against small arms. The slow speed made them artillery magnets. Shell fragments severed control cables. Direct hits detonated the payload prematurely. Some Goliaths got stuck in rough terrain. Ground clearance 11.4 centimeters. Any significant obstacle stopped them. Shell craters trapped them. Rubble blocked them. The Anzio beachhead became World War I trench warfare. Static lines, artillery duels, constant bombardment. Goliaths needed open approaches, clear sight lines, covering fire. They rarely got all three. By May 25th, Allies broke out. 6th Corps pushed inland. 29,200 Allied combat casualties total. 4,400 dead. 18,000 wounded. 6,800 missing or captured. 37,000 non-combat casualties. Malaria, disease, exhaustion. Germans lost 27,500. Rome fell June 4th, 1944. 2 days before D-Day. 11,000 aircraft. At least 10,000 Allied casualties on D-Day. Germans had prepared the Atlantic Wall, concrete bunkers, artillery positions, machine gun nests, beach obstacles, mines, Rommel's asparagus in the fields, booby traps, barbed wire, and Goliaths, positioned along probable invasion routes, stored in concrete bunkers, ready for deployment against landing craft, against tanks, against infantry concentrations. The Goliaths never got the chance. Allied naval bombardment began before dawn. 14,000 shells per hour. Battleships, cruisers, destroyers. Artillery tore through German positions. Shells severed Goliath control cables before operators could deploy them. Those that did launch faced immediate artillery fire. British soldiers on Gold and Sword beaches encountered disabled Goliaths. Control cables cut by shrapnel, vehicles abandoned, explosive charges intact. Soldiers examined them, photographed them, called them beetle tanks. Some tried to operate captured units. The control systems were simple enough, but without targets and with Allied air superiority, Goliaths were curiosities. Most ended up as trophies. A few went to intelligence units for technical analysis. By June 11th, 5 days after D-Day, 325,000 troops were ashore. 50,000 vehicles, 100,000 tons of equipment, Normandy beaches secured, Germans in full retreat. German forces were withdrawing, equipment abandoned, explosives removed, vehicles left behind, too slow to evacuate, too heavy to carry, of minimal tactical value. SS units brought them into urban combat, used them against barricades, against strongpoints, against concentrations of resistance fighters. The Poles responded tactically. Acknowledging minimal anti-tank weapons, Home Army commanders sent volunteers forward. Mission: cut Goliath control cables. Dangerous work. Required getting close. Within direct fire range, but effective. Polish fighters learned the cable location. Rear compartment. Trailing behind the vehicle, one cut stopped the Goliath, rendered it immobile, left 100 kilograms of high explosives sitting in the street. Poles recovered some, stripped them for explosives, used German charges against German positions. Poetic reversal. Between 150,000 and 200,000 Polish civilians executed. Germans destroyed 85% of Warsaw, systematically, house by house, building by building. The SS shot captured insurgents on site until mid-September. After September, some received prisoner of war status, roughly 15,000. Small mercy. Germans lost approximately 20,000 killed and wounded. 310 tanks and armored vehicles destroyed or captured, including multiple Goliaths, some captured intact, some destroyed in place, some stripped by Polish fighters. After German suppression of the uprising, remaining Goliaths were blown up by Soviet forces, buried in dump pits outside Warsaw, 1946. Archaeological evidence confirms this. Track links recovered from those pits show blast damage. Bent metal? Explosion patterns. One track section embedded in St. John's Cathedral wall, Jacania Street side. Germans drove a Goliath toward the cathedral during the uprising, broke through part of the wall. After the war, that track link stayed. Memorial. Plaque reads, "Caterpillar of a German tank-mined Goliath, which during the Warsaw Uprising broke down the walls of the cathedral." Physical evidence, still visible today. Why did Goliaths fail so consistently? Start with specifications. Maximum speed 6 to 6.8 miles per hour, slower than walking pace. A trained soldier walks 3 to 4 miles per hour, runs 6 to 8 miles per hour. The Goliath couldn't outrun infantry, couldn't evade fire, couldn't maneuver quickly. Ground clearance 11.4 centimeters, 4.5 inches, lower than most curbs. Any obstacle taller than 4 inches could stop it. Shell crater, rubble pile, trench, tree root. The vehicle needed flat, clear approaches. Battlefields rarely provided them. Artillery fragments sliced through. The explosive payload sat in an unarmored front compartment. Any penetrating hit could detonate the charge. Premature detonation, wasted weapon, dead operators if they were close. The Germans knew this. Deployed Goliaths from cover, used smokescreens, provided covering fire, sometimes worked, usually didn't. Copper wire, rubber insulation, unspooled from rear drum as vehicle advanced. The cable provided steering and detonation commands. Cut the cable, kill the Goliath. Artillery shells did this easily. Shrapnel from any explosion, direct fire from any weapon, even a soldier with wire cutters. The cable was visible, obvious target. In Warsaw, Polish fighters specifically targeted cables, developed tactics for it. In Normandy, artillery barrage severed cables by accident. Same effect. The Germans never solved this problem. Radio control would have worked. Borgward built radio-controlled versions for other demolition vehicles. The BI-5 heavy-tracked demolition carrier used radio control, carried 500 kilograms of explosives, could deposit the charge and withdraw, reusable. But radio equipment was expensive, required vacuum tubes, bulky, fragile. The Goliath was supposed to be cheap, expendable, simple. Cable control fit that requirement, made it vulnerable. The 6-mile-per-hour speed meant enemies could see it coming, had time to react, could retreat, could engage, could cut the cable. The element of surprise was minimal, unless deployed from very close range, but that put operators at risk, defeated the purpose of remote weapons. 7,564 units produced. Total cost, millions of Reichsmarks. Material, labor, factory space, for a single-use weapon with high failure rate. The resources could have produced conventional weapons, more tanks, more artillery, more ammunition. The propaganda value was significant. Germans showed Goliaths in newsreels, called them wonder weapons, boosted morale, made people believe in technological superiority. The reality didn't match. Most Goliaths never saw combat. Those that did rarely succeeded. Of 7,564 produced, documented successful attacks are scarce. Kursk mine clearing worked, one attack in southern France worked, maybe a handful of others, not recorded in detail, not enough to justify the investment. Documented specifications, tested control systems, evaluated armor, assessed effectiveness. British forces did the same. Conclusions: ingenious concept, poor execution. The idea of remote-controlled demolition vehicles had merit, reduced casualties, attacked dangerous targets from distance, but the implementation was flawed, too slow, too vulnerable, too dependent on fragile cable. The Allies filed the reports, studied the technology, moved on. After the war, remote-controlled weapons evolved, wire guidance improved, radio control became standard, television guidance appeared, modern military drones descend from these concepts. The Goliath was a dead end evolutionarily, but it proved the concept was worth pursuing. April 1943 to January 1945. 4,929 gasoline models. Total, 7,564 units. 6 dedicated Panzer Pioneer companies operated them. Companies 811 through 816, plus units 311, 312, 313, 314. Panzer detachments 301 and 302. These weren't ordinary engineers. Specialized training, remote control operations, cable management, targeting procedures, tactical deployment. The Wehrmacht invested significant training resources, officers, non-commissioned officers, technical specialists, all for a weapon that seldom worked as designed. Explosive charges detonating prematurely, vehicles getting stuck, operators losing control, enemy fire destroying units, terrain defeating approach, weather affecting performance. Winter operations on Eastern Front proved disastrous for electric Goliaths. Batteries froze, motors seized, control systems failed. Units withdrew electric models from winter combat zones, waited for spring, redeployed when temperatures rose, but combat didn't pause for seasons. Enemy attacked regardless. Germans needed demolition capabilities year-round. Electric Goliaths couldn't provide them. The gasoline model worked better in cold, but still faced all other problems. Zundap 2-stroke engines ran in freezing temperatures, needed proper starting procedure, warm oil, multiple pulls, but they started, ran adequately until other problems appeared. Rain affected cable insulation, water penetrated rubber coating, caused shorts, lost control signals. Operators couldn't steer, couldn't detonate, vehicle rolled uncontrolled or stopped. Either outcome wasted the weapon, wasted the mission, put operators at risk. Goliaths couldn't cross. Engineers tried laying planks, tried building fascions, tried clearing paths. Sometimes worked, usually didn't. Terrain defeated technology. Control box temperatures rose. Operators sweated. Concentration wavered, mistakes happened, wrong steering input, premature detonation, target missed. Every environmental factor created new challenges. No environment proved ideal. Goliaths needed perfect conditions. Battles never provided them. Kursk Offensive, July 1943. 312th Panzer Company Funklink used Goliaths clearing paths for Ferdinand tank destroyers. 654th Heavy Tank Destroyer Battalion. 8-9 Ferdinand vehicles, each weighing 65 tons. Couldn't risk mines, needed cleared approaches. Goliaths proved useful, rolled ahead, triggered mines, detonated obstacles, created safe corridors. Ferdinand's advanced. This mission succeeded, one of few documented successes. Context matters. Soviet minefields were extensive, millions of mines, multiple defensive belts, manual clearing too slow, too dangerous, too many casualties. Goliaths offered alternative, faster, fewer casualties, higher success rate against static defenses, using available assets. Goliaths positioned near choke points, road junctions, bridge approaches, urban intersections, waiting for Allied armor, operators concealed nearby, cables hidden, vehicle camouflaged, Allied tanks approach, operator activates. Goliath rolls forward, usually spotted immediately. Tank commander calls warning. Machine gunner engages, tracks shredded, cable cut. Goliath stops, doesn't reach target. Sometimes operators tried smoke cover, sometimes worked briefly, usually failed anyway. Allied infantry learned to watch for cables, follow them, find operators, kill or capture them, eliminate threat completely. Casino, Rome suburbs, coastal towns. Urban terrain helped somewhat, buildings provided cover, streets channeled movement, but rubble blocked paths, destroyed buildings created obstacles, Allied demolitions complicated approaches. Every Italian city was pre-bombed, pre-artillery, pre-ruined. Goliaths faced maximum difficulty, minimum success. Warsaw streets, August through October 1944. Polish Home Army controlled sectors, built barricades, furniture, rubble, vehicles, sandbags, defended strongly. Germans needed breakthrough capability, used tanks, used artillery, used Goliaths, sent them against barricades. Sometimes broke through, sometimes stuck, sometimes destroyed. Polish fighters adapted quickly, learned Goliath vulnerabilities, developed counter-tactics. Cable cutting most effective, also used concentrated fire, Molotov cocktails, improvised explosives, whatever worked. Goliaths stopped being threats, became obstacles. German forces continued deploying them, orders from command. Use available weapons, Goliaths available used them. Results irrelevant, orders were orders. The weapon that was supposed to revolutionize combat engineering became a footnote, an interesting failure, a technological dead end that still taught valuable lessons. Every front proved same limitations. Every battle demonstrated same problems. Every action report recommended improvements. Headquarters ordered modifications. Field units requested changes. Engineering staff attempted solutions. Nothing fixed fundamental flaws. Speed couldn't increase. Armor couldn't improve without excessive weight. Cable couldn't be eliminated without expensive radio equipment. Ground clearance couldn't change without major redesign. Each problem interconnected. Solving one worsened another. The design was trapped. Evolutionary dead end. No path forward. Only path was abandonment. Germany never officially abandoned it, just stopped emphasizing it, let it fade, replaced it quietly with other weapons, other tactics, other failures. Minimal tangling, but external placement made it vulnerable. Any hit on rear compartment could jam the drum, stop cable deployment, immobilize vehicle. The joystick control box was ergonomic, simple operation, minimal training required. Left-right steering, forward-reverse detonation, 3 basic functions. But lack of feedback meant operators couldn't tell if cable was cut, if vehicle was stuck, if target was reached. Blind operation. Required visual contact, limited tactical flexibility. Detonate at optimal moment. All 3 rarely happened. Against tanks, specifically, the Goliath was nearly useless. Tanks move, maneuver, use terrain. By the time Goliath reached where tank was, tank had moved. Against stationary targets, better options existed. Artillery, aerial bombardment. Satchel charges placed by engineers, all more reliable, all less expensive, all proven effective. The gasoline engine in later models came from Zundap SG7, standard motorcycle power plant. Reliable in motorcycles, less reliable in Goliaths. Different application, different stress, different maintenance requirements. Engine overheated easily, small displacement, high load. Cooling was marginal. Air-cooled 2-stroke under heavy armor in combat conditions. Recipe for problems. Mechanics improvised solutions. Better ventilation. Modified cooling. Reduced operational time. Helped somewhat. Never solved completely. Production continued anyway. Orders from above. Keep building. Keep deploying. Keep trying to make it work. 325 modified gasoline models. Last variants. Barely distributed. War ending. Units destroyed, abandoned, captured. Few saw action. Most discovered post-war, in warehouses, in bunkers, in scrap piles. Modern militarized drones use similar principles. Remote control, explosive payload, expendable platform. But modern versions fly, move fast, use sophisticated guidance, have real-time video feedback, centuries of advancement. The Goliath was 1940 technology trying to solve modern problems. Cable vulnerability, slow speed, limited terrain capability, not worth the investment. Better to improve existing weapons, better to use proven tactics. The Red Army had numerical advantage. Didn't need technological gimmicks. Quantity was its own quality. Mass production of T-34 tanks, mass production of artillery, mass conscription. These won battles, not remote-controlled toys. Saw potential in remote weapons. Invested in research. Developed radio-controlled demolition vehicles, aerial drones, guided bombs. Post-war programs expanded. Led to modern unmanned systems. Predator drones, Reaper drones, Switchblade loitering munitions. All descendants of concepts proved in World War II. The Goliath failed tactically, succeeded strategically, showed what remote weapons could be, showed what they shouldn't be. Both lessons valuable. Propaganda exceeded capability. Style over substance. Better to focus on fundamentals. Better training, better tactics, better logistics. These won wars. The Wehrmacht didn't separate Goliath casualties from general pioneer casualties. Operators were combat engineers, faced all normal engineer dangers, plus additional risks from specialized equipment. Anecdotal accounts mention operators killed by cable backlash, by shrapnel from destroyed Goliaths, by artillery targeting control positions, numbers unknown. Context: combat engineers generally suffered higher casualty rates than regular infantry. More dangerous missions, less cover, forward positions. Goliath operators added remote weapon risks to standard engineer dangers. The systematic destruction of Warsaw included Goliath attacks, not the main method. Artillery and demolition teams did most, but Goliaths contributed. Photographic evidence shows Goliaths in Warsaw streets. German propaganda photos, combat photography, later used as evidence of German tactics. The track link in St. John's Cathedral wall. Physical proof, permanent reminder. Electric motors were expensive, required copper, specialized facilities, skilled workers. Batteries needed lead, sulfuric acid, careful assembly. Each electric motor cost approximately 800 Reichsmarks to produce. 2 motors per vehicle, 1,600 Reichsmarks just for propulsion. Add battery costs, 400 Reichsmarks. Control system, 200 Reichsmarks. Hull fabrication, 300 Reichsmarks. Explosive charge, 200 Reichsmarks. Assembly and testing, 300 Reichsmarks. Total, 3,000 Reichsmarks minimum, some estimates higher. Quality control added costs. Testing procedures required time, trained personnel, dedicated facilities, but still required allocation of resources, factory space, workers, materials. Every Goliath meant fewer motorcycles for military use. Wehrmacht needed motorcycles, dispatch riders, scout units, military police, civilian government functions. Every engine diverted reduced motorcycle availability, trade-offs, command decisions, prioritization. Already invested resources, already built infrastructure. Borgward factory in Bremen dedicated production lines. Zundap facility in Nuremberg similarly committed. Workers trained, tooling manufactured, supply chains established. Canceling production meant admitting failure. Wasting investment, propaganda consequences. The wonder weapon narrative required continuing production. Public morale depended on technological superiority messaging. Even if reality contradicted propaganda, maybe next deployment would succeed, maybe next battle would validate the concept. Never happened. Each battle proved the same failures, same vulnerabilities, same limitations. Modified explosive charge configurations. None solved fundamental problems. Speed still inadequate. Armor still minimal. Cable still vulnerable. Terrain clearance still insufficient. The engineering staff knew. Field reports documented problems consistently. Technical evaluations recommended cancellation. Command ignored recommendations, ordered continued production, deployed units anyway. Hoped for miracles, got casualties instead. Technical specifications evolved slightly through production. Early electric models, 1.5 meters long, 0.85 meters wide, 0.56 meters tall, 370 kilograms. Later, electric models, minor improvements, better sealing, improved cable drum, reinforced track links, small changes, incremental. Gasoline models, 1.62 meters long, 0.84 meters wide, 0.6 meters tall, 430 kilograms. Bigger, heavier, more powerful. Same fundamental problems. Speed still 6.8 miles per hour maximum. Ground clearance still inadequate. Armor still minimal. Cable still vulnerable. Later models. Declining quality, rougher welds, thinner paint, substitute materials. Reflected overall German production degradation, 1943 to 1945. bombing campaign effects, material shortages, forced labor replacing skilled workers, quality control declining. But even early high-quality Goliaths failed operationally. Manufacturing quality wasn't the problem. Design was flawed. Concept had merit. Execution was inadequate. Technology wasn't ready. Tactical doctrine wasn't developed. Combination of factors. Royal Museum of Armed Forces and Military History in Belgium, Polish Army Museum, Warsaw Uprising Museum, especially significant. Local historical connection, direct combat use, the St. John's Cathedral track link, most accessible memorial, public location, free viewing, historical context explained. Visitors can see the physical evidence, touch history, understand the reality. Some are electric models, recognizable by flat top plate, 3 deflection rollers, disc-shaped idler. Some are gasoline models, visible engine air intakes, different hull profile, modified track idler. Most are incomplete. Missing control cables, explosive charges removed. Some are cutaways, internal components visible, educational displays, explain operation, show limitations, demonstrate why they failed. Physical objects are powerful teachers. Seeing the actual size, the minimal armor, the basic construction, understanding becomes immediate. These weren't super weapons, these were desperate measures, technological experiments, expensive failures. Control cables worked, explosive charges worked, but integrating them into an effective weapon system failed. The engineering was adequate, the tactical application was not. Battlefields were too chaotic, targets too mobile, defenses too effective, terrain too varied. The concept needed better technology, needed radio control, needed real-time video, needed faster speeds, needed better armor, needed smarter targeting. All impossible in 1944, decades away. The Germans tried anyway, built 7,564 units, deployed them across Europe, hoped for success, got failure, learned lessons. Everyone learned lessons. Satellite navigation, digital communications, advanced sensors, none available in World War II. The Goliath operators had wire, joystick, visual observation. Sometimes smoke obscured targets, sometimes cable broke, sometimes Goliath got stuck. Operators improvised, tried different tactics, learned from failures, kept trying. The Wehrmacht kept deploying them, even after clear evidence of ineffectiveness, kept hoping, kept believing. Wonder weapons would turn the tide, technology would overcome numbers, innovation would defeat brute force. It never did. Wars are won by logistics, training, strategy, industrial capacity, not by expensive experimental weapons with poor combat records. Bad execution. Wait for better technology. The concept was filed away. Research continued quietly. Decades later, remote-controlled weapons emerged. Effective, reliable, tactical game changers. The Goliath's legacy lived on, not as a successful weapon, as proof of concept, as warning about premature deployment, as lesson about matching technology to doctrine. These lessons cost Germany millions of Reichsmarks, cost operators their lives, cost civilians their homes, expensive education. Contains multiple Goliath hulls, stripped, blown up, buried, forgotten, until excavation decades later. Recovered track links, now in collections, now telling stories. The cathedral wall link, most public memorial, most accessible. Thousands see it yearly. Most don't know what it is. Plaque explains. German tank mine track, Warsaw Uprising, 1944. Simple words. Complex history, physical evidence of technological overreach, of tactical desperation, of strategic miscalculation. One small piece of metal, enormous story. Became permanent, cathedral rebuilt around it, preserved, memorial, reminder, physical proof, not propaganda, not legend, not estimate. Actual artifact from actual combat, confirmed origin, documented location, verified date. Historical fact, solid, undeniable, real.